Hey guys, it's a little sample of the music you missed at lunch help today. Alright, cool. So I'm just going to go through the practice test with you in case you're interested in hearing some of those answers and how to do those questions on the practice test. Okay, question 1, practice test. Write the direction vector of the line described by the parametric equations. X equals -3 plus 2t, y equals 2 minus t, and z equals 7. So I'm writing the direction vector of the line. So I know the direction vector is the things that are with the t. So all the coefficients with the t. So my direction vector for this line would be 2. This one would be a -1. And you notice this one does not have a t, so 0. That's the direction vector of the line. So the things that are right with the t's tell you the direction vector. Since this one doesn't have a t, it would be like 0t. And then the other numbers, the -3, the 2, and the 7, describe a point that's on that line. Cool, so that's the answer to question 1. Question 2. Write the equations of two three-dimensional lines that do those 3 things. Okay, so there could be multiple answers here, but I'm just going to go through one way to do it. So if we're trying to say they intersect at -3, 7, 2, so that means we've got 2 lines not accurately drawn, and we know they're going to intersect right at that point. So things I know. Okay, I know they share that one common point. So if I'm going to make 2 equations for like line 1 and line 2 that intersect at that one specific point, then the easiest way I would think is if I make that point this guy right here. I'm thinking, because this vector is describing like a point on a line. So if I just make that intersection the point, that seems good. And then all I need is a direction vector for my lines, and I don't really care what that is. As long as they're not the same, I can make them whatever I want. Because I know this direction is different than this direction, so it doesn't honestly matter. I can make this one 0, 1, 4, -1, 2, 1. So now I know I have equations, lines going in different directions, but they're going to intersect at that same point. That's not the only way to do this, but I think that's the most straightforward way to do it. Okay, then it also says we want to create 2 equations that will never intersect. So that could mean you're creating a couple of skew lines, perhaps, that won't intersect. Maybe you want to do that. That seems harder. Or you could be creating a couple of parallel lines, which seem easier to me. So I'm going to go that route. So if I wanted to make a pair of lines that never intersect, okay, so they're going to have a point. That's not going to be the same. And then they'll both have to have a direction vector, and I'm thinking I want my direction vectors to be the same or like scalar multiples of each other. So 1, 2, 4, I'm just picking out of my hat. I could just make it exact same for simplicity's sake. So I know these are parallel, or I could have made that a scalar multiple. And then I just want to pick points that I know are not going to be on the same line. So however you want to do that. So maybe I make it like 0, 0, 1, and -2, 4, 1. And if you just want to test it, because you're like, ooh, what if I accidentally made this point on the other line and then they're actually coinciding lines or something, which would be crazy. But if you just want to test it out to make sure that you just created a set of parallel lines, you could try subbing a point in. So if I take line 1 and I make a couple parametric equations, I got 0 plus t, y equals 0 plus 2t, and z equals 1 plus 4t. And then if I just want to sub in my point for x, y, and z, so if I sub in these values, so if I say -2 equals t, 4 equals 2t, and 1 equals 1 plus 4t. So I know t equals -2. In this example, t would equal 2. And in this equation, t would equal 0. because I move the 1 over. 1 minus 1 is 0, divided by 4 is 0. So I see that all the t's are different, so that means that this point here doesn't lie on line 1. So that tells me that line 2 is different than line 1. So sweet, that's what I wanted. Okay, and my third thing I have to do is I have to make a pair of lines that intersect at a right angle. So more than one way to do this, but just thinking, if I got some lines, I don't really care where they intersect. I just care, the only thing I care about is that they intersect at all, so they're going to have one point that's in common. So hey, what up? I might as well make that point the same, so maybe I'll make it that point. Just pick that randomly. And then I want my direction vectors to be perpendicular to each other, because I want them to be at 90-degree angles to each other. So, how can I make that happen? Okay, so I know something about perpendicular lines. I know I could take the dot product and it would equal 0. So if I took my two direction vectors and did the dot product, they would equal 0 if it's a 90-degree angle between them. So maybe I'll just make up one, like 1, 1, negative 1. So now I know if I'm going to do my dot product, I do, and this one, I'm not sure. I'm just going to fill it in with x, y, z. So if I do 1 times x plus 1 times y plus negative 1 times z, I want that to equal 0 so that my direction vectors are perpendicular. So you can go with whatever you want. So say I just wanted to keep it easy. Maybe I want that to be like 0. That could be a 1. That could be a 1. So that would make it 0 plus 1, which would be 1, minus 1 would equal 0. So take out x, y, z and make it 0, 1, 1. That could work. Cool. So now I know these are perpendicular to each other, so they would be at a right angle, and I know they have a point in common. Awesome. Okay, question 3. This one's tricky. So write the equation of the line that's created by the intersection of the plane that contains those points and the other plane. Okay, so essentially we've got two planes. So plane number 1, we're given 3 points. 0, 1, 2, 2, negative 1, 3, and 3, 0, 5. And then plane 2 is 3x minus 2y plus 4z minus 6 equals 0. So I got two planes. So more than one way to do this too, but I think I'm going to turn these into a scalar equation of a plane. Because it's good practice too. So I want to turn these into a scalar equation, just like plane 2 is in. So to make a scalar equation of a plane, that's the one that looks like ax plus by plus cz plus d equals 0. And I know that a, b, and c are actually my normal vector. That's a, b, and c. Okay, so if I call these points P, Q, R, to create a normal vector, well, I'm going to need some direction vectors that are actually on my plane. So I'm going to do that by just picking some points. So I'm going to find my vector PQ. So I'm just going to take Q minus P. So 2 minus 0 is 2, negative 1 minus 1 is 0. And, oops, that's not right. Negative 1 minus 1 is negative 2. And 3 minus 2 is 1. Okay, so that's PQ, and then I'll do QR. You can do any, whatever. So 3 minus 2 is 1, 0 minus negative 1 is 1, and 5 minus 3 is 2. So I created two direction vectors that are on my plane. So essentially what I've got here is a plane. I've got 3 points on my plane. Then I took my points and I created two direction vectors. Now with those direction vectors, I can actually take the cross product of them. I can do the cross product of PQ and QR. And that can give me my normal vector, which would be perpendicular to both of those direction vectors. Cool. So let's do the cross product of those direction vectors. So 2, -2, 1, 2, -2, 1, 1, 1, 2, 1, 1, 2, and then I just do my diagonal line trick. So -4 minus 1, 1 minus 4, 2 minus -2. So I've got -5, -3, 4. I hope I did that right. Let's just check. -4 minus 1. 1 minus 4. 2 minus -2, which is like 2 plus 2. Cool. So that's actually my normal vector. And you can always reduce your normal vector to lowest terms, which it looks like it is already. So if we're going to write the scalar equation of this plane, we can replace a, b, and c with -5, -3, and 4. And now we just need to figure out what d is. And to find d, we can just take any one of those points and sub it in. So I'm just going to use my point 0, 1, 2 and sub that in to find d. So -5 times 0 minus 3 times 1 plus 4 times 2 plus d. So -3 plus 8 plus d. So 5. So d is equal to -5. Sorry, so the scalar equation of my plane is -5x minus 3y plus 4z minus 5 equals 0. Plane 1, that's our scalar equation, if I didn't mess it up. Hopefully not. Tell me if you see a mistake I made. Okay, so that's not the whole question. We actually have two planes, so 3x minus 2y. Sorry, let me just write plane 2 down. 3x minus 2y plus 4z minus 6. Plus 4z minus 6 equals 0. So that's plane 2. All right, so we haven't actually started the question really, because the question says, write the equation of the line that's created by the intersection of the planes. So we've got two planes. There's plane 1. And plane 2. Oof, that's rough. Okay, so we've got two planes that I can't draw. And they intersect in a line. Okay, let's think about a textbook. If this is like one of your planes, and that's like the other plane, the spot that they intersect is actually makes an equation of a line. So two planes intersect in a line. All right, cool. So we know a line actually has the equation, like it has a point, and it has a direction vector. So we're trying to figure out a point and a direction vector. We're trying to make our equation that looks like this. So if you'll notice, there's a parameter here. So that makes sense because we have two equations here and we have three unknowns, x, y, z. It's impossible to find a point that's going to intersect on those planes. And the reason is that's because there's an infinite number of points. It doesn't intersect at one point, it intersects at many points. So we're just going to try to find that equation where they intersect. Okay, so first goal. We want to eliminate one of these variables. So we're going to add or subtract these equations or multiply them or something. Not multiply the equations together, but like multiply one equation by some number. So we want to look at the coefficients. So 5 and 3 are not the same. -3 and -2 not the same. 4 and 4, those are the same. Cool, so let's try to get rid of the z's. So we're going to subtract these equations from each other. So -5 minus 3 would be -8x. -3 minus -2 is like -3 plus 2, so that would be -y. 4 minus 4 would be 0. -5 minus -6 would be 1, because -5 plus 6 equals 0. So we just eliminated z. Perfecto. So we just found out nothing. We just isolated x and y. And we can't solve that. We can't figure out x and we can't figure out y, which is fine. We don't want to. We are trying to create an equation of a line. So you know what? We're going to go ahead and I'm going to go ahead and let x equal t. You got to pick one variable to equal the parameter, and I'm going to let that be x because that way y is easier to isolate because there's no coefficient in front of y. So that's why I picked the x. So if I'm letting x equal t, if I want to solve this equation for y now, then I can say negative 8x plus 1 is equal to y. And I'm just going to replace the x with a t. Cool, so I just solved for y. So I got x equals t, and I got y equals 1 minus 8t, if I rearrange that. So I got two equations, and now I just need to know what z equals. So I'm going to take one of my equations from up here, the purple or the black one. I'll just take the purple one. And now I'm going to solve for z. So I've got 3x minus 2y plus 4z minus 6 equals 0. Okay, I'm going to isolate z. So 4z equals 6 minus 3x plus 2y. And I'm just going to sub in my x and my y. So 4z equals 6 minus 3 times t plus 2 times negative 8t plus 1. So 4z equals, just simplifying all of this, 6 minus 3t minus 16t plus 2, if I haven't made any mistakes. So 4z is equal to 8 minus 19t. Oh, nice. Okay, so then I need to isolate z. So z is equal to 8 divided by 4, which is 2, and 19 over 4, which I can't simplify, so that's what z equals. So I'm going to add that in here. So 2 minus 19 over 4t. So there you go. I just subbed stuff into each other, and I found the parametric equations for my line, x, y, z. If I wanted to turn that into a vector equation, I just take my point first, which is all the constants. So x doesn't have one, so 0. Y's constant is a 1. And z's constant is a 2. Plus, then I go through my parameter stuff. So x has a 1 in front of the t, y has a negative 8 in front of the t, and z has a negative 19 over 4 in front of the t. So that's my vector equation, and this is my parametric equation. And that's for when the two planes intersect. I've just created the equation of that line. All right, so that was the practice quiz, or practice test for C3 and C4. Hope that helped.